Today we are going to find out how iPhone 7 NFC circuit works. NFC, also known as Near Field Communication. It operates at the frequency of 13.56 MHz. All iPhones since the iPhone 6 support NFC functionality. It is mainly used to support NFC-based payment transactions. For Apple Pay and bus transit in some area. With the non-stop unlocking process of NFC functionality by Apple, Apple users will benefit more and more from its convenience in daily life. First, let's take a look at main components on the NFC circuit. NFC_RF, NFC controller. It works to communicate with CPU and manage the NFC circuit. It also completes transferring, modulation and demodulation of data transmitted. U0700, CPU. It is responsible for overall control of the NFC circuit. With its communication with the NFC controller via UART bus. CPU also gets the NFC circuit into power on self-test process. And performs as function controller and data transmitter. U1801, PMU. It works to provide power supply for the NFC circuit. And receive NFC wake signal. MU_RF, baseband PMU. It works to provide clock signal for the NFC circuit. Now let's find out how iPhone 7 NFC circuit really works. First, PMU will output PP1V8_SD RAM to the NFC controller. Meantime, PMU will output an enable signal to the NFC load switch. With the enable signal fulfilled, VDD_main can provide power supply for the NFC controller. By way of the NFC load switch, VDD_main is also supplied to the NFC boost chip. With PP1V8_SD RAM and the main power supply fulfilled, the NFC controller will send out a clock request signal to baseband PMU. Baseband PMU will then send a reference clock signal to the NFC controller. Then, CPU will send a device wake signal to the NFC controller. With the signal fulfilled, the NFC controller will then get to work. Then, CPU will send drivers to the NFC controller via UART bus. As the NFC controller gets power supply, clock signal and drivers, it will then go into the power on self-test process. If the NFC controller is malfunctioned, the power on self-test process will also fail. And therefore result in stuck on Apple logo issue and iTunes error code 56. Which is commonly seen with the NFC circuit. When the NFC function of the phone is enabled, the NFC controller will be in standby mode, so as to get prepared for signal receiving, transmitting. The transmitting process of NFC. When there are data waiting to be transmitted, CPU will send a data load request signal to the NFC controller. The NFC controller will then send a boost enable signal to the NFC boost chip. The NFC boost chip will then form a boost circuit with L7502_RF. The 5 volts voltage generated by the circuit is supplied to the NFC controller. These data to be transmitted are sent to the NFC controller by CPU via the UART bus. After the encryption and modulation process by the NFC controller, these data are then sent out by way of the antenna. The receiving process of NFC. External RF fields, like those from NFC bus card readers and NFC entrance card systems, can be detected by the built-in NFC antenna of the phone. Once detected, the corresponding signal will be transmitted to the NFC module by the NFC antenna. After the demodulation and decryption process by the NFC module, these signals are transmitted to CPU by way of the UART bus. CPU will then identify and verify these signals. And if these signals are verified to be emitted by the trusted device, CPU will start the communication task with the device. Also, if the bus card account of the phone is bound with a SIM card, Communication between the SIM card and the NFC controller will be completed by pin 6 of the SIM card with the help of the SWP technology via the NFC protocol interface. The authentication and deduction are processed by the SIM card and the card reader together. Please be noted that pin 6 of ordinary SIM cards is an empty pin that has no NFC functionality. For NFC-specific SIM cards, we need to apply to carriers for issued cards. Now let's move to diagnosis and maintenance of iPhone 7 NFC circuit. Once we have confirmed that the fault has nothing to do with external causes like software or SIM card, we should run cosmetic inspection of NFC circuit relevant area on the board. If nothing goes wrong with the NFC function enabled, measure working voltage of the NFC circuit. R7520_RF, 3.4 volts to 4.3 volts. C7520_RF, 5 volts. C7502_RF, 1.8 volts. If nothing goes wrong, check relevant circuits of the NFC controller. Specific steps are as follows. Detach the NFC controller from the board and run diode mode measurement of its bonding pad. If the measured value of one specific bonding pad is abnormal, then check relevant circuits of the pad. If the measured value of all bonding pads is normal, then replace the NFC controller. If the fault shows up as a signal problem, we can take one lever of tweezers as an external antenna and connect with nodes on the antenna circuit one by one. If the NFC signal is back to normal with one specific node, and communication between devices is back to normal, then the fault component is the one connected with the node. If all nodes fail, check relevant circuits of the NFC controller as steps mentioned above. Common fault components of the NFC circuit. Malfunction of the NFC controller will result in issues like stuck on Apple logo issue accompanied with iTunes error code 56, or failure of the NFC function. Malfunction of the NFC boost chip will result in failure of the NFC function. And this is our detailed explanation of how iPhone 7 NFC circuit works. Feel free to visit our official website www.driwatechnology.com. See you next course.